Okay, we're up to problem number 15 on the review final. And this one, very similar to the last one in some ways, or at least it's a follow-on. The last one was finding polynomial zeros of these high-degree polynomials. And this one actually breaks out the factors, which means that you know the zeros, or at least you can easily figure what the zeros are. And then it's just a matter of using the degree, the leading coefficient, and the zeros themselves in order to figure out what the graph looks like, where it crosses the x-axis, where it crosses the y-axis, that kind of thing. So here we go. Let's just go ahead and do that. Let's break it down. First of all, some things we want to do first is look at what is the degree. And to find the degree, what we have to do is add up all these exponents. And remember that x has a 1 there. So basically, this is 3, 4, 5, 6. This is a degree 6 polynomial. What's a 6-degree polynomial look like? Well, if it has a leading coefficient, it's going to have 5 terms. If it has a positive leading coefficient, it's going to come down, it's going to turn 1, 2, 3, 4, 5, and look like that. But we've got a negative leading coefficient, so that turns it upside down. So in a general way, that's what the function's going to look like. Now, some of these could get scrunched together, and we'll figure that out. But it's down, down. Right, is the thing. It's when we graph it, we're going to start low, we're going to wiggle, and then we're going to end low. Okay, that's the primary thing. Okay, zeros. We've got 1 at 0 itself. Okay, so what value would I put in for x here to make the entire polynomial 0, and that would be 0. Okay? And in fact, when the x is 0, the y is 0, and that tells us that our y-intercept, and I'm just going to go ahead and graph that, is 0, 0. Okay, that way we're not worried about trying to calculate some crazy y-intercept. Okay, the next one is -3 makes it 0, and there's actually 2 factors that look like this. So I've got a -3, -3. Okay, 4 would make this factor 0, and I got 3 of them. So 6 degrees, 6 zeros. Okay, there's an odd multiplicity at 0. There's an even multiplicity, and then again there's an odd multiplicity of 4s. And if you remember the rule, let's get it over where you can see those zeros. If you remember the rule, if there's an odd multiplicity, we're going to go through the x-axis. So we're going to go through the x-axis here, one direction or the other. At -3, we're going to bounce because it's even. So we're going to bounce. Obviously, we're going to have to come back down, but then we come back up. We're going to go through. And then we're going to come back down at 4, and we're going to go through again. So 1, 2, 3, 4. So don't worry about replicating all these squiggles in the middle, because in real applications, sometimes those just get so scrunched up that you can't really tell. The main thing is that the main things we're looking for: end behavior. Where does it go on the ends? And are we correctly bouncing and going through. So let's just go ahead and draw this. I'm going to start way down low. I'm going to bounce. I'm not going to worry about how far this goes down. I'm not going to worry about how far that goes up. All I'm going to worry about is whether I bounce or go through, and whether my end behavior is down and down. And if you get all those things, then that is all you have to do on this problem. It's actually pretty quick and easy. This should be one of the more relaxing problems on the test.